let's solve some real-world problems. So many real-world problems can be solved using logarithms. Knowing how to solve exponential equations using logarithms allows us to solve for an exponent. So given a desired amount and a starting value, we can find out just how long it takes to reach that desired amount. So a sum of $5,000 is invested at an interest rate of 5% per year. Find the time required for the money to double if the interest is compounded according to the following method. Right? So we're going to find out if it's compounded semi-annually, if it's compounded continuously. All right, so let's do the first one. All right, so we're gonna do the compounded semi-annually. So remember that equation, we have a set number of times we're compounding, is that our amount at the end of some time is going to be equal to our principal times 1, because you keep all your money, plus you get a % more, and you get that every time it's compounded. And the number of compounding periods is going to be our exponent, so NT. Right, and we have some of the information we need. We know, for instance, that the ending amount, if we want it to double, means we want $10,000. We're starting off, let me move this over a little bit. There we go. We're starting off with $5,000. Okay. And then our interest rate is 5%, so that's 0.05. And it's compounded 2 times a year, right? This is semi-annually 2 times a year. And we're going to solve for the time. That's what we don't know. We don't know how long it's going to take. All right, so we're going to plug in a 10,000 for the amount equals our starting value of 5,000 times 1 plus 0.05 divided by 2 to the 2t power. Okay, and we're going to solve for our exponent. Now what we have to do first is we need to isolate our base. And right now we got a complicated base, right, because we got 1 added to something, and then we've got something in front. Right? The first thing I want to do is get rid of the something in front, right? So that, and then I'll work on that base. Right, so we'll divide both sides by 5,000 because that's our starting amount, and that's a coefficient. We can't have that there. All right, so, well, 10,000 divided by 5,000, that's just 2. That makes sense because we want our money to double. All right, so 2 equals 1. Let's simplify this 0.05 divided by 2. Right? That's just going to be 0.025, right? And it's going to be or 5%, it's going to be 2.5%. Come on, go away. I'll just write over it. So 0.025. There you go, to the 2t power. Well, that's just 1.025, right? So we have 2 equals 1.025 to the 2t power. And now we need to take a log. Now it has to match the whatever has the exponent on it with the variable. And the term with the exponent with the variable is the 1.205. So this is going to be our base for our log. And it's going to be 1.205. So we've got log 1.025 of 2 equals log 1.025 of 1.025 to the 2t power. Right? So I wish I had more space here. I shouldn't have wrote this so big. Maybe we can move that up a little bit. I'm running out of space here at the bottom. I'm going to try to move everybody up at the same time. Come on, move up. There we go. All right, so now power rule, that 2t is going to move in front, right? And I'm going to try to do 2, well, maybe I better not do 2 steps at once. I don't want to confuse you. So we have log 1.025 2 equals, this would be 2t, right, times log 1.025 of 1.025. Right? So even though this base looks terrible, it really isn't going to be any more difficult to calculate out with because your calculator is going to do all the work for you. It doesn't matter really what the base is. All right, so this right here, remember, was the power rule. We were able to move the exponent in front, and we know that log and a base with the same result, that's just 1, right? The power I have to raise 1.025 to get 1.025, that's just 1, right? And now we're going to use the change of base formula over here because we definitely don't want to keep that base. So let's just make it natural log. I did a lot of log base 10 in the last lesson. So we'll have natural log of 2, the result, divided by natural log of 1.025 is equal to 2t. And since we don't want 2t, we want t, we're going to divide both sides by 2, or multiply by 1/2, because that's easier for me to write. All right, so if we put into the calculator 1/2 natural log of 2 divided by natural log of 1.025, we're going to find out how long it takes for you to double your money with that interest rate and that compounding schedule. All right, so let's find out how much it is. So it's natural log of 2 divided by natural log of 1.025. Right, I'm going to I'll hit enter, hit that whole thing and just divide by 2. So it's going to take you 14.036. So 14 years plus, a little bit more, like 10 days more or so. And there we go. So now we're able to not only find out how much we'll have it after a certain amount of time, we can say, hey, I want to know how long will it take to get to this certain amount, right? So now we can solve for the exponent. And so I know this looks like a lot of writing, but really it wasn't very difficult. It wasn't any more difficult really than those other problems we did, except our base was a little funky, and we had to write the equation first. Let's solve the other one, which is what happens if it's continuous. And actually, this is an easier equation to solve because we have a really friendly little formula, right? Our amount is our principal times E is our base if it's continuous, right? Whenever we see continuous, we know E is the base. Right? So we have PE to the RT power. Right? And so we know A of t, right? It's going to be $10,000 because we want our money to double. We're starting off with 5,000. Our interest rate is 5%, and time is what we're solving for. So 10,000 equals 5,000 e to the 0.05 t. Looks a little simpler already, doesn't it? We got to isolate e, right? So we're going to divide both sides by 5,000. Right, so now we have 2 equals e to the 0.05 t power. And what do we use for e? That's natural log. So natural log of 2 equals the natural log of e to the 0.05 t power. We can use our power rule, right? Power property, rule property. The exponent moves in front. So now we have natural log of 2 equals 0.05 t, natural log of e. But natural log of e is just 1, so I don't need to have that there. So we have natural log of 2 equals 0.05 t, but I don't want to know what 0.05 t is. I want to know what t is. So we'll just divide both sides by 0.05. Not natural log 0.05, just 0.05. So our exact answer is natural log of 2 divided by 0.05. But maybe you want to have a more common answer. All right, so if we take natural log of 2 and we divide that by 0.05, it'll take us 13.8629 years. Okay, so notice it's going to take us less time because your money was compounded continuously. You got interest all the way through, not just at the end of the compounding period. And that's all there is to this problem. So really it's just like the exponential equations we were solving before, but we have to write the equation. So we're kind of putting everything together. We write the equation just like we did when we were evaluating, and then we also solve for our exponent, just like we did in the last lesson. All right, so let's take a look at this one. I have this color-coded. I'm going to try to write in the same color as my steps on the side there. And I think these are the ones in your notes. And I included all the steps for you. So how long will it take for $5,500 to grow to 8,000 at 3% annual interest compounded monthly. I have to say these ones where we have compound interest and it's not continuous are the most difficult ones. All right, so this is the hardest problem that you'll solve. All right, so we're going to use our compound interest formula. So, and I'm just going to write above it so I can have all the space. So this is our principal, that's what we're starting with. This is what we want to have, that's our ending amount. There's our R, but it's 0.03. And the compounded monthly means that N is 12, and we're solving for T. We don't know how long. All right, so we have 8,000 equals 5,500 times 1 plus 0.03 divided by 12 to the 12t power. That looks like RT power. Now that I try to keep the interest something that divides evenly by whatever the n is. All right, so we have to divide both sides by 5,500 because we have to isolate the base, and that base is that 1 plus blah, blah, blah. All right, so, well, this will reduce a little bit. The zeros will cancel. And 80 and 55, they're both divisible by 5. So that's going to be 16 over 11. That's a nice base, isn't it? Or a nice number there. Not a base, but nice number. 16 11ths equals, and that'll cancel. So we'll have 1 plus 0.03 divided by 12, all to the 12t power. Now let's simplify that base there. 0.03 divided by 12 is going to give us 0.004? No, 0.025. 0.025, right? 1/4. So 0.025 plus 1, that's going to be 1.025. If we add 1 to it to the 12t power. Oops, I said I was going to write in the same color as the step, and I didn't. I totally didn't. So I'm sorry. I'm just going to start this problem again because I did want you to be able to patch it. All right. Sorry about that. All right, so pay attention now. A equals, or I write the formula. A equals P times 1 plus R divided by N to the NT power. All right, let's substitute in. 8,000 equals 5,500 times 1 plus 0.03 divided by 12 to the 12t power. And actually, I said to simplify in parentheses first. It actually doesn't make a difference if I divide and get rid of that number and then simplify, or I simplify and then I divide. So, but I'll follow my steps that I have written over the side there. So 8,000 equals 5,500, and now we know that this is 1 plus 0.025. So I'm just going to put I'm just going to put that. All right, there we go. Now we'll divide both sides by 5,500. So either order was correct. That doesn't make a difference whether I divide first and then simplify, or I simplify and then divide. Got something funky going over in the center there. All right, so that's going to reduce. We saw that's going to be 16 11ths equals 1.025 to the 12t power. So now we're going to take a log in the same base. So we have log 1.025 16 11ths equals log 1.025 1.025 to the 12t power. The power rule can move in front, right? So we have log 1.025 16 11ths. I really probably should use parentheses just because the way it looks. Not that it makes any difference. Equals 12t times log 1.025 1.025. I'm writing in my steps there. All right, and so log 1.025 of 1.025, well, that's just 1. So our whole expression over there is just 12t. We're going to use the change of base formula here because, gosh, we don't want to keep that base. So it's the log of the result, so log or natural log 16 11ths divided by the old base, log 1.025 equals 12t. All right, and now we just have to divide both sides by 12. All right, so the exact answer is going to be 1/12 times log 16/11 divided by log 1.025 equals t. But if you told someone that's going to how long something's going to take, they'll think you're crazy. So let's change that to a number that's maybe a little easier to talk about. All right, so that would be log 16 divided by 11. And we'll take that number and divide by log 1.025. And we'll take that number and divide by 12. Because that was compounded, it was 1/12. Oh, that does not seem right at all. Like I hit something wrong on my thing here. Because I had to take 1.26 years. And that's not right. Didn't write anything wrong. Don't see any mistakes. Probably hit into the calculator incorrectly. Let's try that one more time. So log, otherwise, 16/11 divided by log, maybe I hit natural log on one of them, 1.025 divided by 12. That seems crazy. Did I write down that I bet you 1.025 wrong? Let's see. Did I miss a 0 in there? Divided by 12. Yes, I missed a 0. All right. That explains a lot. I'm like, that answer is crazy. All right. So we need to add in a 0 everywhere we see that number. Boy, this problem was just doomed from the beginning, wasn't it? All right. That's what I get for remembering what the number was, for missing a 0. But I quickly recognized that that would just not be possible. In 1 year, you're going to earn $3,000. If that were true, I want to know what bank you're banking at because, darn it, I want to bank there too. Okay, one more time. Log 16/11, should have that memorized, divided by log 1.025. All right, and then divide that by 12. I hit the same thing again. Ugh. We'll get this right. And I don't want to record this. I just really want it to be that number, I guess. All right, last time. We will not make a mistake. 1.0025. And then divide by 12. Yes, finally, it's going to be 12.505 years. So final answer is T equals 12.505 years. That was exhausting. One little 0 missing. Boy, what a difference that makes. That would be the correct answer. So if you get an answer that just doesn't make sense, make sure you haven't decided to leave off one of your zeros. All right? Like I did in this one. All right? So that's called what not to do. Let's do one more problem. And this one's a nice, easy one. So that one was all hard because we had a compound a certain amount of times. We had to simplify in the parentheses. I had to change the base form. This one's so easy. I'll color code it again like the colors that are over there. All right, so compounded continuously. This is our starting value. You invest $20,000 at 6.5% interest. Compounded continuously. When you see the words compounded continuously, that means E is the base. Yay for E. All right, we want our money to triple. All right, so that means that our ending value is going to be 20,000 times 3. So that's going to be 60,000. All right, our principal is 20,000. And our interest rate is 0.065. Come on. And time is what we're solving for. So these ones are really easy. So 60,000 equals 20,000 e to the 0.065 t power. My words come up so much after I write them. Got to divide both sides by 2,000 because we need to isolate e, 2,000. So we have 3, which makes sense because we're tripling our money, equals, come on, e to the 0.065 t power. We'll take a natural log of both sides because e is our base. So we have natural log of 3 equals natural log of e to the 0.065 t power. 0.065 can move in front. Right? So we have natural log of 3 equals 0.065 t, natural log of e. But we know natural log of e is just 1. Right? So we have, I'm going to isolate our variable here. So we have natural log of 3 equals 0.065 t. And if we divide both sides by 0.065, come on, I already wrote that up there. Maybe it's not going to, oh, there it goes. We want to divide both sides by 0.065 because we don't want to know what 0.065 t is. We want to know what 0.065, what t is. There we go. So the exact answer is that t equals natural log of 3 divided by 0.065. And our approximate answer on how long that is natural log of 3, close that parentheses, divided by, because I don't want to take natural log of 3 divided by 0.065, which is what will happen if I don't close the parentheses. 16.902 years. I'll just put 16.9. 16.9 years, so not quite 17 years, 16.9. And there we go. That's how long it'll take for your money to triple with that interest rate. So maybe you're saving for a really nice car, right, or a college education. And you want to know how long it'll take you if you got $20,000? That's how long it'll take you if this is your interest rate. All right, so we'll do more problems in class like this one, not this one here. Right? In this case, we need a certain time, and we're going to be solving for the interest rate. Actually, the problem's really not any different than the one you just did. It's just a different variable you're solving for, but it's actually almost the same steps. All right, but we'll solve this one in class. Bye for now.